Briefly touch upon the experiments that we have conducted to learn the chapter Magnetic Effects of Electric Current. Grade onwards, the pedagogy must be learning centric and not teaching centric. I have explained this to all of you. Additionally, you see the knowledge of physics can best be acquired by experiential learning. This process is augmented by structured homework, tests, examinations, and that will lead to better understanding of the topics. The students who learn intensely, passionately, joyfully can be coached further. Okay, this is a hybrid classroom wherein I have students who are seated in front of me, as well as the students who could not come here. They are sitting online and enjoying this class. I have this intelligent panel which has got so many features and facilities to make teaching really very effective. And this chapter on magnetic effects of electric current can best be understood by experiencing magnetism in real time. And I have about 20 experiments, and I have taken around 15 classes to all of you. Alright. You will watch short clippings of the experiments conducted. Closer, then you can see some movement, then it got attracted. So why this magnet is always pointing towards the geographic north? Magnet. Okay, see now you can see all these magnets. See, you can see the small magnets here. Are they getting affected?
Yes, sir.
A coil like this, which has got 50 turns. This needle has turned like this. So that means there must be one more magnetic field which is influencing it. Right? So now, the position of this magnet here, of this small magnet here, is the resultant of two magnetic fields. Leave the magnet. See, now it is stationary. Now I leave my hand. Okay. Thread to the thread, I have connected some magnetic discs. Okay. Now these magnetic discs have got north pole, south pole. North pole, south pole. Understood? Each of these discs has north pole, south pole. Now, what you have to understand is that there is something called as magnetic lines force, which I will be explaining to you. But if you have seen the book, you would have seen this there.
Yes.
So what are these red color things that I am drawing?
Magnetic field.
Magnetic field lines. They are imaginary. You don't, so when you make the magnet move down, what happens? The magnetic field will be linking this coil. Here, supposing I take a, is there any deflection?
Yes, sir.
Both of them are moving. Can you see deflection?
No, sir.
Huh?
No, sir.
See, if both of them are moving, no deflection. If one of them moves with respect to other, there is deflection. So, the right word you should use relative motion. See, this magnetic needle is representing what? See, this vector is representing what? The magnetic force on this magnetic needle. This white color is a vector which is showing what? Magnetic force on this magnetic needle. These force vectors are tangential to a circle that I have drawn. With lines represent magnetic field lines. Magnetic field lines. Hello, is that clear?
Yes, sir.
Okay? Now, right? You can see I am sprinkling it. Bar. So this is it. See, again you see the north pole, south pole. It is tangential to this point. Okay? So I bring it here. Again you will see the similar phenomena. That is, but now you see that they do not cross. That is very important. Okay?
What if you break at the center like
Louder.
What if you
There is a hollow copper tube. Okay? And it is held vertical of the magnet, not through the rod, but from this height. And you have to observe 2, 3.
Yes.
Yeah, it hardly took 1 second to reach the earth into the copper tube. Okay? And when I say you drop 3.
Yes.
It's falling, fall. It took almost 3 seconds for the magnetic piece to fall through this rod. It is approximate time taken for this was hardly 1 second. Hardly 1 second. So it had a free fall. Okay. Now, when this object, when this object was inserted into this, and then it was let to freely fall. It was let to freely fall. Again it came down here. This object came down here. Okay, and this time it took almost 3 seconds to eddy currents. Understand? So it is because of eddy. The compass I have kept a coil. Okay? This is a coil, and this is a magnet that is suspended, and then you have got a ammeter. Alright? So now I am going to switch on, and the current will start flowing in this coil. Field will be created. Good. Right. Continue.
Compass will deflect according to the relative magnitude.
Compass. So I just now turned on right hand. So the thumb is pointing in the direction of current, and my fingers are motor here. Okay, can you all see? Hello. So how I am demonstrating this is because, okay. So see here, if the current is flowing in clockwise direction, the magnetic field is entering into the frame of this coil. Flowing in the coil, right? You saw that the magnetic needle rotated in this direction. Now I am passing current through the wire. Did you notice some change?
Yes.
What is the change you noticed?
Coil of wire.
It's this. You understood Fleming's left hand rule,
Yes, sir.
right?
Yes, sir.
And this is also called motor rule, downward direction. And this portion of the coil is pivoted. The coil is pivoted. Pivoted means what? It is held like this, so that this coil can rotate. Can you understand?
Yes, sir.
The coil, you can see, and the ends of the coil are connected by wire to the galvanometer. I think all of you can see this galvanometer. And then you can see I have kept a magnet here, a very powerful magnet here, very close to this coil. Alright? Now so no current is flowing. Right? Now I am going to, well, you saw what I did. Now can you see the deflection in the galvanometer?
Yes, sir.
As the coil is moving, field is more. Got it?
Yes.
So now here you see, the coil is rotating. Sometimes this end is this side, the next cycle this end will come this side, this end will come here. Whatever be the thing, hello, the current in this bulb is always flowing in this direction. Do you appreciate that?
Yes, sir.
Hello?
Yes, sir.
So here, please understand that this connection what they have done here, this line that they have brought here, it should not be connected to the brush. ನಾನು ಎಷ್ಟು ಡಯಾಗ್ರಾಮ್ ತೆಗೆದೆ? ನಿಮ್ಮ ಅನುಕೂಲಕ್ಕೆ ಇಷ್ಟೊಂದು ಡಯಾಗ್ರಾಮ್ ತೆಗೆದಿರಿ. ಈಗ ನೀವು ಎಷ್ಟು ಬೇಕಾದ ಡಯಾಗ್ರಾಮ್ ತೆಗೀರಿ. ತೆಗೆದ ಈಗ ಕೂತ್ಕೋರಿ 15 ನಿಮಿಷ ಅದನ್ನ ಮಾಡೇ ಹೋಗ್ರಿ. Understood? You sit here, you complete the homework and go. Mechanical, I am shooting it here. Actually, the wire will come here and it will get soldered. Then the other end connector, I will pass it through this. Can you see?
Yes, sir.
Board? Then to this also, I will connect. Alright, so here as you have seen so far now, I have shown you just 30-second clipping of every experiment that I have shown. Okay? So it will be a ready reckoner for all of you, and you should appreciate that experiential learning is a teaching strategy that links field, laboratory, the classroom experiences with real life situations and applications. In experiential learning process, science students are exposed to real life experiences through controlled experiments and other ways. As you have seen, I have got the experimental setup here and we have all performed the experiments. So controlled experiments and other ways where theories of science are brought to life through series of applications suited for particular grade students. So you are 10th grade, so these experiments are all conducted for your level. I suppose this was all helpful to all of you. Thank you so much.